In the section 7.1, we already know how to construct the confidence interval for estimating a population mean, but at that time, we know about the population standard deviation. And for these sessions, we'll be working on the same thing, but they don't given the population standard deviation. Instead, they will be given the sample standard deviation. Okay, sample standard deviation is given. In this case, we'll be using a new distribution. Okay, this is called the student t distribution. Instead of using a normal distribution z, okay, this is something new. On the chapter 6, we only focus on the normal distribution. We never talk about the student t distribution. So I want you guys highlight here. When we want to construct the confidence interval for the population mean and sample standard deviation is given, okay? S stands for sample standard deviation. So look at the student t distribution. Okay, look at this picture. You're gonna see the black line here. This is called the standard normal, okay? This is talking about your z distribution, okay? The one we're working on the chapter 6 or the part 1 from here, okay? The black one, that will be the standard normal distribution. And for the t distribution, I want you guys to look at the brown one here, okay? The brown line in here. You could see compare with the standard normal, the t distribution is going to be more spread out, okay? The more spread out. And this is specific like t with 1 degree of freedom, okay? I'm going to explain what is the meaning of the degree of freedom later, okay? You could see t equal to 1 when you have a small degree of freedom. The distribution is more spread out compared with the standard normal. If we increase the degree of freedom to 4, that with the blue one here, it will be approximate, close to the standard normal. If we keep increasing the degree of freedom until to the 10 here, that would be the red one, really close to the standard normal distribution. Okay, so the student t distribution is also looks like the normal distribution. It's just more spread out and it is symmetric. Okay, symmetric. And in the middle is 0, so the t distribution can be positive or can be negative here, just like the z-score. And then we need to know how to find the degree of freedom. Okay, we need to know how to find the degree of freedom. Okay, now let me explain what is the meaning of degree of freedom. Definition: degree of freedom for a collection of the sample data set is the number of the sample values that can vary after certain restrictions have been imposed on all data values. So what is the degree of freedom? Look at this example. If 10 test scores have the restriction that the mean is 80, okay? So on this example, my restriction is the sample mean has to be equal to 80. So think about it. I have a 10 test score. So this is my 10 data. And I want to find out the sample mean. So I add it all up divided by 10 in here. It has to be equal to 80. This is my restriction. Now, I'm gonna multiply by 10 for both sides. Okay, so multiply by 10 here, cancel out. Multiply by 10 here, I got the 800. So means like sum of 10 data has to be equal to 800. What does the degree of freedom means? Degree of freedom means for the first 9 data here, it can be anything. I could make up any value for the first 9 data. But for the last one, it has to be fixed because after I add the last data, I will be make sure it has to be equal to 800. So in this example, I would say my degree of freedom will be 9. I do have a 9 degree of freedom to assign any values. But for the last one, it has to be fixed in order to get the 800. So how can we find the degree of freedom? It's going to be equal to n minus 1. Okay, if we have a 10 data, means I have a 9 data of degree of freedom. If I have a 20 data, means I do have a 19 data of degree of freedom to assign any values. Okay, using the TI-84 plus calculator, find the critical value of T alpha over 2. Okay, you're gonna see this time my critical value become the T, okay, instead of the Z. Means we are using the student T distribution instead of the normal distribution. And you could see I only say using the TI-84 plus calculator because only TI-84 plus calculator have this function. If you are using the TI-83 plus calculator, you need to do the programming. I already posted the YouTube video to teach you guys how to do the programming for the inverse T. Again, if you're using the TI-83 plus or TI-83 calculator, you need to do the programming in order to use the inverse T here. If you're using the TI-84 plus calculator, you will be fine. Just follow like this instruction. So we're gonna do the second bars. You're gonna find out the inverse T here. Okay, inverse T. And then you need to put in like two numbers. Area to the left, similar to the Z distribution. And then comma, degree of freedom. Again, degree of freedom is going to be n minus 1. And then look at the positive number. Your positive number here, that will be your critical value. I will show you guys how to use the calculator with this example. Okay, simple random sample of size 13 is drawn from a normal population. Find the critical value for a 90% confidence interval. So first, we know the sample size is going to be equal to 13. The step is similar with the first two examples, how to find the Z critical value. So we have assumed this is a normal distribution again, and 90% in the middle. So in the middle is going to be 0.90. Figure out what is the area on each tail. So it's going to be 1 minus 0.90 divided by 2, which is going to be 0.5. Okay, exactly the same step, just like the example 1 and 2. Now, what is the critical value? We'll be using the inverse T, area from the left. Again, find out the total area from the left. So you could add up these two numbers, which is going to be 0.95, or you could do 1 minus 0.05, comma, degree of freedom, n minus 1, okay? Sample size is 13, 13 minus 1 is going to be equal to 12. So you should get 1.782. Okay, let me show you guys with the calculator. Second bars, you're going to see the number for inverse T. Enter, area from the left, 0.95, comma, and then degree of freedom, n minus 1, which is going to be 12. Enter. You can see my calculator is running right now, 1.782. Okay, 1.782. If you go to the second bars, you didn't find the inverse T. I know like some TI-84 calculator, they may not have this function either. So again, you need to do the programming. Okay, I post the YouTube video on Canvas. So watch that video, follow the instruction how to do the programming in order to use the inverse T. You need to know how to do that because on the chapter 8, we need the inverse T again. Okay, procedure for constructing confidence interval for population mean when population standard deviation is unknown. Okay, so this is talking about S is going to be given. Okay, sample standard deviation is given. So simple random sample and the central limit theorem. Okay, population is normally distributed or sample size is going to be greater than 30. So first, find out the degree of freedom and the critical value, just like the previous example. Second, find the margin of error. This formula is really similar to the part 1. Only difference is this is a T and they use the Z. and the S, okay, they're using the S. This is a sample standard deviation, okay, sample standard deviation. After you know the margin of error, construct the confidence interval. And then conclusion, okay, really similar. Okay, example. Sample of 123 people, aged 18 to 22. Report the number of hours they spent on the internet is an average week. Sample mean was 8.2 hours with the sample standard deviation of 9.84 hours. Highlight the sample standard deviation. Okay, this is the S. When S is given, we want to use the student T distribution. Okay, and assume this is a simple random sample from the population of the people aged 18 to 22 in the United States. Construct 95% confidence interval for the population mean. Population mean. The population mean number of hours per week spent on the internet by the people aged 18 to 22 in the United States. Okay, first, let's verify the conditions. The sample is a simple random sample, right? Simple random sample. And then either the original population is normally distributed or sample size has to be greater than 30. And then we have the sample size is going to be 123. So sample size greater than 30. Now, I want you guys try to find the critical value. Since the S is given, right? Sample standard deviation of 9.84 hours. So we'll be using the T distribution. So you should have the inverse T, including the area of the left tail, that will be 0.975, and then the degree of freedom, which is going to be n minus 1. You should get 1.98. And then margin of error, use this formula. So one more time, we'll be using the T distribution. So you do have the critical value, T alpha over 2, which is we got it from the previous part here. And then S, that's a sample standard deviation. That will be 9.84, sample size 123. Try to use your calculator. Okay, you're gonna get 1.7567. Find the confidence interval. So we do have the sample mean, which is gonna be 8.2 hours, plus minus the margin of error. Okay, we have the margin of error, get it from the step 2. Okay, you're gonna get 6.44 to 9.96. And then draw the conclusion. I need you guys state the complete sentence. First, we do have a 95% confidence level, right? And then you're gonna look at like the statement here. Population mean number of hours per week spent on the internet by the people aged in this group. Okay, so I'm gonna say we are 95% confident that, then you're gonna copy this sentence. That is in between what you look for the confidence interval. Okay, let's try to use the calculator to check your work. Okay, so we're gonna go to the stat, go to the test, go down. Okay, this time we are working on the T distribution, confidence interval. Okay, the part 1 will be using the Z, right? This time we're using the T distribution, confidence interval. Enter. And then we have the statistics summary. So sample mean, that will be equal to 8.2. The S here, this is a sample standard deviation, okay? Make sure the question is given the sample standard deviation. That'll be 9.84. Sample size and 123. And we are working on 95%. So 0.95. Calculate. Okay, enter. So you should get 6.44 and 9.96. Okay, 9.96. Okay, you could follow this procedure on your notes. Suppose you do a study of acupuncture to determine how effective it is in the relieving pain. You measure sensory weight for 15 subjects with the results given. Use the sample data to construct a 99% confidence interval for the mean, okay, the mean, for the population from which you took the data. So this time they're gonna give you the data set instead of the statistics summary. Okay, first, verify the conditions. Simple random sample. Okay, we believe this is a simple random sample. And then we're gonna look at the sample size. We have 15 students, right? So n equal to 15, which is less than 30. But they're gonna state that the population is assumed normal. Okay, so we assume the original population is normally distributed. Find out the critical value. And since they give you the data, right, you don't have the population standard deviation. From the sample data, you only can get the sample mean and the sample standard deviation. So for the critical value t here, first determine what is your sample size. What is your n equal to? You do have a 15 data, right? So n equal to 15. So the degree of freedom will be equal to n minus 1, which is going to be 14. And we are working on 99%, okay? So you should have this number here. Inverse t, 0.995, degree of freedom, n minus 1. You could get 2.977. Okay, step 2, find the margin of error. Since they're given the data set only, we don't have the statistics summary. We don't know what is the sample mean. We don't know what is the sample standard deviation, right? Do you guys remember how to find out the sample mean and the sample standard deviation if I give you guys a set of the data? Remember the midterm 1, if I give you guys the data, how can you determine the sample mean and sample standard deviation? You could use the formula or you could use your calculator. So let me show you guys how to do it. I'm gonna go to the stat, number 1 added. So let me clean up the data here, highlight the L2, click clear, enter. Highlight the data, highlight the L1, click clear, enter. So now I'm gonna plug in this data. We have a 8.6, enter, 9.4, 7.9, 6.8, 8.3, 7.3, okay, input the data. So we do have a 50 data in here. Now go to the stat, go to the cal, choose number 1, one variable statistic. Second, 1 for L1. Enter. So we have the sample mean and we have the sample standard deviation. Try to get more decimal space, okay? Don't take only 1 or 2, okay? I need a 3 decimal space here, so you want to take more than 3 decimal space from the data. So let me write it down, my sample mean and sample standard deviation. Now, find the margin of error. Okay, check your work. You have the critical value here times sample standard deviation divided by the square root of 15. You should get 1.285. And then plus minus the sample mean. Okay, you have the sample mean plus minus with the margin of error. You should get this. And then draw the conclusion. So we are 99% confidence interval. Okay, and the weight is going to be in between these two numbers. Okay, check your work with the calculator. So for this one, they give us the data set instead of the statistic summary. So I already have the data set on my L1. Now I'm gonna click on the stat, go to the test, go to the T interval. We are working on the T distribution confidence interval. And I will choose the data here, okay, because we have the data. And then my data set is on L1, okay, so I keep it for the L1. Frequency, keep it as 1. We are working on 99%, so 0.99. And then calculate. So double check your work. You have the confidence interval 6.94 to 9.51. And then double check your sample mean 8.2267 and sample standard deviation 1.6722 and the sample size is going to be 15. That's it.